All right, guys, this is the SLO review packet. And I have put on here the slides, the parts of the reference sheet that go with it. For example, these first two questions, you need this part of the reference sheet that you will have. Does that look familiar? It's on the top of your blue sheet that you've had this semester, okay? The most important thing, and like Katie said, I'm going to make you a copy of exactly what the ones are going to look like. I'm just going to make them on white paper, but I'll make you a copy of what the reference sheets are going to look like so you're not freaked out and you can't find stuff, okay? I'll have them for you. I'll try to have them for you tomorrow. This is the important thing. These formulas only work when you're in radians. So what do we need? Okay, so the first question is about arc length, I think. So we're going to need this formula. The second question is about linear velocity. But to find linear velocity, we need angular. And angular is radians over time, it says here. So we're going to have to find that and then convert it to a linear by multiplying by r. Is everybody okay? Knows what those mean, where they are on the reference sheet. All right. So who can help me with problem number 1? Okay. So the 11 centimeters is going to be the r, but the theta is not just 80. It has to be what? How do we change it to radians? 80 pi over 180. Everybody okay? And now it's radians. And it wants to the nearest tenth, so we don't need to do any reducing. We can just type it in. (11 times 80 times pi divided by 180. I have 15.4. Anybody else? Label. If it's an arc length, so it's centimeters. Remember, radians just kind of disappear. All right. Take a second, look at number 2, see if you can tell me what you think we might need to do. Pretty much. There's a couple that have some multiple choice, but that's it. Pretty much all free response on this one. I think there's a total of 25 multiple choice on the other part, and then a few more free response. But okay, so we need to find an angular velocity, which is radians per time. Do we have that right now? What is this 4,000 business? What do we need to do? One revolution is 2 pi radians. Then we'll have, and I'm not going to bother, it's just going to be 8,000 pi radians per minute. And then to get linear, what does it say to do to that angular? Here's the slide again. Multiply it by the radius. So we're going to take that answer and multiply it by 5 centimeters. And then we're supposed to find it to the nearest tenth again, including a label. All right, my label back here is confusing. This should be radians per minute. So what is that going to happen when we do radians times centimeters divided by minutes? Yes, a linear is a distance per time, so we're going to have centimeters per minute. It doesn't ask us a particular label, so we're going to go with the easiest one that's there, right? We're not going to convert to meters per hour for fun or anything. Go right ahead and I'll try to figure out if it's right, but it would make more sense to just do the easiest. They didn't tell us, so we're going to go with the labels they gave us. We type all that in, I got a really big number. 125,663.7. Any questions? In my opinion, just writing an answer down on a review packet does absolutely nothing, right? If you're going to go back and look at it again later, you need to be able to remember how you did it. So, all right. Ideas on number 3? All right, so left 5 and up 12 we'll say is over here somewhere. Then what? Do my little bow tie triangle, right? Connect it to the nearest x-axis and to the origin. I went left 5 and up 12, so everybody could put those in the correct spots. Am I going to need the other one? Cosecant is what? And that's on your reference sheet. It says cosecant is 1 over sine. Or its sine is what? Opposite over hypotenuse. So this one's going to be hypotenuse over opposite. So we do need the hypotenuse. So 12 squared plus negative 5 squared equals hypotenuse squared. We get 169 square root and we get 13. Unless we forget the parentheses around the negative and then we get it wrong. All right, so hypotenuse over opposite. The angle theta is actually this angle, but its reference angle is here. So hypotenuse over opposite is just 13 over 12. Everybody okay? All right, what are we doing on number 4? We're just looking at the unit circle. We're finding 5 pi over 3. Wasn't that what it said, guys? 1/2 negative square root of 3 over 2. Let me just write that down so we can talk about it. Okay. Cotangent is the flip of tangent, or it's cosine over sine, or it's x over y. Do we have to deal with the denominators, guys? We practiced this, right? We don't need, they'll always drop out. So basically, if we put cosine over sine, we'll have 1 over negative square root of 3, which is negative square root of 3 over 3. If we do some rationalizing, everybody good? Doesn't matter where you write the negative. Okay. We spend a ton of time doing those. Those were like on 10 quizzes in a row. I feel like those use the unit circle to find stuff. Maybe not 10 quizzes, but a lot. Okay. Read this one. Tell me what you want to try. You do have to have some kind of explanation for this question. And there are several different things you could use. How do you decide what quadrant? Which means positive, yes. And it says over here, sine is negative. Some of you will do this. Remember that? Which, by the way, could you just look at the unit circle? Where are the cosines positive and the sines negative? Yes? Quadrant 4? You'll have that unit circle, right? And it even says it here. Cosine is positive, sine is negative, right there. All right, so we would write that quadrant 4 because the cosine is positive and the sine is negative. It's good enough for me. We need to find tangent, so I'm thinking we need to do what? Yep, I would go with a sketch. I'm going to put this onto the sketch, right? Okay, but we don't know the cosine. All right, the sine is opposite over hypotenuse, right? So if I draw this, where am I going to put the 7 and the 25? How did I know the negative one on the 7? Because it went down 7, and because the hypotenuse is never negative, right, guys? Everybody going to remember that? Hypotenuse never gets a negative sign. All right, this time I have x squared plus negative 7 squared equals 25 squared. I do Pythagorean theorem. 24. Okay, now what? Tangent is opposite over adjacent, or y over x, which would be any questions? Is tangent supposed to be negative in that quadrant? Yeah. Who's got this one? Yep, because it says all, we're going to need plus or minus 2 pi n, or just plus, I don't care. Yes, we're going to take a cosine out. What will it say then? Now we have two things that multiply to make 0, and that's the only time we can separate them and set them equal to something, right? You can't have something times something equals 1. Some of you did that on a quiz, and I was totally confused. Okay, if they equal 0, then one of them has to be 0. So if the cosine is 0 or the cosine is 1/2, if I go to my unit circle, it says to answer in radians. Where am I looking for cosine? Yes, the x coordinate. There's a 1/2, there's a 0, there's a 0, and there's a 1/2. Everybody okay? So what am I going to write? I can't on this one. I could on this one. Pi over 3 and 3 pi over 2, I'm sorry, pi over 2 and 3 pi over 2 are straight across the unit circle from each other. You can write both of them and say plus or minus 2 pi n, but if you wanted to only write one of them and say plus or minus pi n, that would be fine. But the other two, are these two where it's 1/2 across from each other? No, these, I can't shortcut anything. I could actually. I could say they're plus or minus pi over 3 because this is a negative pi over 3 because it has symmetry, but it's fine to just say this. Don't spend extra time trying to figure out the shortest way to write it. Everybody okay with those 4 answers? Everybody understands why it was radians and why it had to plug the plus or minus? All right. Now, before you get all crazy with this question, read what it asks for, because I was reviewing this yesterday and I was like, okay, we got to do this, this, this. But only thing it asks for is what is the what? period. Okay? We don't care about this number or this number, right? This number affects the period. That's B. I'm not really grading you on whether you found B. I'm grading you on whether you can find the period. Do you remember how that works? It's 2 pi divided by B. So it's 2 pi times the reciprocal of this, because we got to flip it over. What's going to happen? Yeah, pi will cancel and we get... Now, could I type that in my calculator if I left the pi off? Could I type 2 divided by 3/5, math, enter, enter? And it would give me 10/3, okay? Some of you get all freaked out when there's fractions. All right, the next question, equally messy, but only thing it asks is what? Phase shift. Do you remember which is a phase shift? Is that up, down, left, right? Yeah, phase shift is in here and it's left or right. Phase shift is always left or right. Well, that's a nice arrow if you're trying to tell me left or right. It's like diagonal. So this one is what? Pi over 6 to the right. Now, it will be in factored form, okay? Remember there was somewhere they weren't factored and we had to factor it. It's in factored form, so it's not meant to confuse you. All right, number 9, there's only one where you have to do all 6 ordered pairs. And it doesn't have, you know, a vertical shift and a phase shift and a amplitude change and it's upside down and it's got like 2 things going on. Probably roughly like this one. What's this one have going on? Amplitude is 4. 2 pi divided by b is 2, right? So we have a period of pi. So it's going to go up as high as 4, down as low as -4. It's going to finish an entire cycle by pi. Where does it start because it is a cosine function? Starts at the maximum, yes. It's got to finish here. So halfway in between there, it's going to hit the minimum. And halfway in between there, it's got to cross. All right. It would actually curve. Oh, that's really bad. Just don't make it look like a V and I'll be happy, okay? It's going to curve that way. And it would curve back this way. It says at least one period. If you want to draw more, you can. But I want 5 ordered pairs from within one period. So who can give me one? 0, 4. Halfway to pi over 2 is pi over 4. Everybody okay with that one? Pi over 2, -4. Oh, that's D. This is E. Questions on that? If I promise it doesn't have a phase shift, we're good. Yeah. All right. Graphing. Coming up with an equation from the graph. Okay. No. I wish we could write a negative cosine. It says you must write a sine equation. Well, this is, okay. Must write a sine equation. But do we have to look at it as a sine to be able to find all these things right here? Only the phase shift is the only one that matters that it's a sine graph. The amplitude is the same no matter what kind of graph it is. If it goes from 2 to -4, that's a total distance of 6. So the amplitude is 3, and the midline would be at? Do I need to go back over how we did that? Is everybody okay with that? All right. I don't have to look at it as a sine graph yet. I can look at it as anything I want. I can start anywhere I want and finish one cycle. How long did that take? If I started here and finished here, was that one cycle? And it took till pi. So 2 pi divided by pi makes the b value just 2. Right. Now, unfortunately, we do need to look for a sine shape. Can I start right there? And that would be a sine, a positive sine graph. It doesn't say you can't do a negative. If you want to do a negative, that's fine. But if I start right there, what would the shift be to the right? Right. Now, do you remember how to plug all those things in? This is generally how we did them. This one is amplitude. This is just b after you've taken care of 2 pi over the period to find b. This is the phase shift. And this is the vertical shift. It's okay with me if you want to put the plus d out in the very front up here. Doesn't matter. But make sure you put parentheses around the x minus the. If you put the b in the parentheses, it's going to be wrong because your shift will be wrong. Okay. If you put the b in with the x. Okay. Who's got this? Anybody? If you leave off this one and this one, I wouldn't count it wrong. Okay. But those the calculator would bring up. So you would have to have double parentheses if you were typing it in to check it. -1 on the back further down. Well, good. Okay, so take a minute and try number 11. This one is just on here for extra practice. There's not 2 the same on the actual test. It does. Anybody have at least the amplitude? The period? Okay, it's okay to look at it as a cosine, and it finishes a cycle here at 3, right? So b is going to be 2 pi over 3. What was the vertical shift? In other words, the midline. Yep, positive 20. Everybody okay? All right. Now the phase shift for this one is a little tricky. here in between here, what's halfway to 3? So this is 1.5, or this one right down here, this dot is negative 1.5. Halfway to negative 1.5 would be what? Negative 0.75. So this is a negative 0.75 over here. Oops, I wrote that wrong. Or this is a positive 0.75 over here. Or if you added it onto the 1.5, this is actually a 2.25 there, if you wanted to do that one. Would it be all right with you if we just went to the left of 0.75? There's more than one right answer, but is that a sine graph right there? Okay, so I'm going to go with left 0.75. You could have gone with a negative sign and a right 0.75, or you could have gone all the way right 2.25 and gotten it right. All right, who can put it together? Bryson, go ahead. Okay. I'm going to go down here so I don't have to erase all that, okay? I'm going to draw it more spread out. It shows this to be 3, yes, where it finished 1. So halfway would be 3 divided by 2. And then 1.5 divided by 2 would be, and then it's the same on the other side. That help? Yeah. It's really hard to tell on that picture, but. All right, now who's got me for an equation? Love, what'd you come up with? Okay. Anybody have something else they want to check if it's right? Yep, thank you. Did he say minus or did I just write minus? I don't know. It should be plus. Anybody got something else they want me to check? All right. Is this our last graphing one? I think it is. Okay. And there is one just like this. There is more practice on this idea on a couple of the other packets, okay? So this is not the only one for practice, but what can you tell me? Okay, the highest point is 22, and that's where he starts, isn't it? Starts the watch when it's at 22. No. Diameter doesn't have anything to do with the period. What did you say, Danielle? Okay. She said if this is 22, 14 down from that would be at 8, which is, must be like where the little steps are. You come up, you must get on at 8 feet up, right? Everybody okay? Whoops, I shouldn't have drawn a dot there. What else? One revolution every 40 seconds. That's the period, right? Justify your amplitude and period. Time for one revolution is 40 seconds. So the period is 40. What about the amplitude? Okay, you can either say the radius is 14, which is the amplitude. Radius is 7, or the amplitude is 7. My bad. Or you could say if you wanted max minus min divided by 2 would be 14 divided by 2 is 7, which is the amplitude. I don't care. You don't need both of those explanations, but one of them. Do you remember? Sound familiar? Either need max minus min divided by 2 is 7, or you could just say the radius, because it's always the radius on a Ferris wheel question. Now, this business isn't going to help us really when we go to write the equation. That means we're going to put in what? 2 pi over 40 or pi over 20. Yep. And I don't care which you do. I will not count off if you didn't reduce. It's my least of my concerns. Before we graph it, or, oh, thanks. Before we write the equation, we can graph it if we want. It just does, and you're not getting, I mean, you should have a graph there, but you're not having to label points or anything. That's all you need, right? You might want to find the midline from, draw it on there just to make sure it makes sense to you. But that's the other thing we need before we try to write the equation is the midline. If this is 7 and this is 7, it would be at 15. Okay, who's got the equation then? Amplitude, I'm gonna call it a cosine because it started at its max and it says it's okay to call it a cosine. Pi over 20 or 2 pi over 40, I don't care. We don't need a shift, right? So we could have done without the extra parentheses, doesn't matter. Okay. Then to find the height at 11, you have a couple options. You can put your calculator in radian mode and type it in. I already have it in because I did it with 7th grade yesterday. Then you would set your window to look like theirs, and you check it, and you go trace 11. Okay, 13.9. But could I have also done it from the home screen, guys? I could have just put the 11 in the home screen, and I would have still got the 13.9. Okay, I just like to do the graph because then I'm checking that I did the equation right. But all right, please make sure you have all your reviews with you every day to class. Yes. I will be here today and tomorrow after school. Yeah.